Someone uploaded a dataset to Hugging Face. That sounds harmless. A dataset is supposed to be information, rows, text, images, and numbers. But this dataset was different. It behaved more like a hidden program. It allowed an attacker to run commands inside Hugging Face system. From there, the attacker found digital keys. Those keys opened more systems, and thousands of actions were followed. The entire attack was driven by an autonomous AI agent. But here is the twist. AI also helped Hugging Face find the attack and then fight back. Hugging Face is a platform where developers share AI models, datasets, and applications. But because people can upload content on Hugging Face, it has to inspect and process that content. That processing system became the entry point. According to Hugging Face, the attacker used two weaknesses that allowed uploaded data to run code. In simple terms, the platform expected information. The attacker made that information behave like instructions itself. That was the first failure. The system treated the upload as data, but hidden inside it was a way to take action. At first, the attacker reached only the machine processing the dataset. Normally, that machine should act like a locked room. Even if something goes wrong inside it, the problem should remain trapped there. But that did not happen. The attacker escaped that room. It reached the larger system underneath it. And then it found the credentials. Think of credentials as the digital keys. One key may open a cloud account, another key may open a server, another may connect to an internal system. Once these keys were collected, the attacker no longer had to keep breaking from the outside. It could begin moving through Hugging Face using access that looks trusted. One malicious upload had become a doorway into several systems. But this was not it. This was not a normal hacker manually entering every command. Hugging Face says the attack was run by an AI agent system. The agent carried out thousands of small actions. It tried one step, checked the result, changed its approach, and continued again and again at a machine speed. This matters because a human attacker has limits. A person is going to get tired. A person can only examine so many systems at once. But an AI agent, it can keep searching, testing, and adapting for hours without losing its focus. This does not mean the AI was magically intelligent. It means the attacker could automate the patience itself. And in security, patience can be extremely dangerous. Now the story changes. The attacker used AI, but Hugging Face also used AI to detect it. Security systems produce huge number of alerts. Most are harmless. One unusual login may look normal. One stage command may not seem important. One failed connection may also be ignored. But when several small warning signs happen together, they may reveal a much larger attack. Hugging Face says its AI-assisted detection system connected those scattered signals and flagged the compromise. Finding the attack was only the beginning. The team still had to understand what actually had happened. They had more than 17,000 recorded events to examine. Which actions were real, which systems have been touched, which credentials have been exposed, and which events were only distractions. Reviewing all of this manually could have taken days. Instead, Hugging Face uses AI agent to study the logs. These agents help rebuild the attack step by step. They found important clues, they identified which digital keys had been touched, and they separated real damage from misleading activity. Hugging Face says work that would normally take days was completed in hours. But then, the defenders faced a problem they did not expect. They first tried using commercial AI services, the kind offered by companies such as OpenAI or Anthropic, to examine the attack. Hugging Face has not revealed which providers it's actually used, but the security logs contained real attack commands and malicious code. The safety system saw that dangerous content and blocked the request. The AI could not tell the difference between help me launch this attack and help me understand an attack that already happened. So commercial AIs didn't help. So other attacker could use dangerous commands freely. But the defenders could not ask the commercial AI to study those same commands. The safety system did not stop the attack. It slowed down the investigation instead. This is the most surprising part of this incident. Hugging Face eventually used an AI model running inside their own system. That changed two things. First, the investigation was no longer blocked by an outside provider. Second, sensitive logs, credentials, and attacker data stayed within the company. They did not have to send that information somewhere else. This creates an important lesson for us. Many companies are starting to depend on AI during security incidents. But what happens when the commercial AI services refuse to process the evidence itself? What happens when the internet connection is unavailable? What happens when the logs are too sensitive to share with an outside company? A backup AI system may no longer be optional. it may become part of emergency planning itself. Hugging Face says it closed the weaknesses, removed the attacker, rebuilt affected machines, changed exposed credentials, and added stronger protections. It also said it found no evidence that public models, dataset, application, or published software had been changed. The company was still checking whether any customer or partner data had been affected when it published the disclosure. So what should engineers and QA teams learn from this? First, never assume the data is harmless. A dataset, document, image, or configuration file can sometimes make a system perform actions. Test every upload as if it may be hostile. Second, trap risky processing. If one temporary machine is compromised, the attacker should not be able to reach the larger system. The row must remain locked. Third, protect the digital keys. A key used by one service should not open 5 others. Each credential should have only the access it truly needs. Fourth, test your emergency tools before the emergency. Can your AI system examine real attack evidence? Can it do that without sending private data outside? And do you have another option if the main service blocks you? This incident is a preview of how security is changing. AI can help attackers move faster. AI can also help defenders understand the attack faster. But the winning side may not be the side with the smartest model. It may be the side that prepared its system before the attack even began. For more real AI incident investigated from a testing and engineering point of view, subscribe to NextGenQA. Every week, we break down what failed, why it failed, and what engineers should test differently. Because when attacks start moving at machine speed, security teams cannot afford to respond at human speed.